Hello everyone. Good morning, good morning, good morning. Am I audible? Good morning. Good morning. How are you all? How things are going? All the best for your exam. Okay, good morning, good morning, good morning, good morning everyone. Okay, so today we are entering into a new topic, that is ray optics. Okay, today's topic is ray optics, and it is the fundamental of the topic ray optics. In ray optics, the basics starts with light rays, object, images. That is the today's topic. So excited? I'm good. Fahad, thanks for asking. I'm good, too good. How I'm looking at? I am good looking. No, I'm good only. Just kidding. Okay, so I'm good, beta. I'm good. I'm so good. And now I have become better interacting with you all guys. More and more time I will interact, I will become better. So see this, ray optics, focus on this. Okay, thank you. What is object, what is image, what is the fundamental of ray optics, what is the basics of ray optics? You have to decide this. So first thing comes into ray optics is objects. The point is, can we see object? Tell me all of you, can you see an object? Are you able to see an object? In general, from any optical device, what we see is images. We see images. We don't see objects, right? After reflection, after refraction, whatever we see is called image. So point is how we decide object. What is object we cannot see, and something we cannot see, how can we decide what is it? Point is, when we say object, what is object? Object is point of intersection of incident rays. And then a very simple fundamental is cleared. If I want to decide object, I have to decide it according to incident ray. I cannot see something and I can say this is an object. That object we talk in daily life is different from the object we are talking in optics. Optics objects are decided by incident rays. It is not at all decided by any other thing. You have to understand this, right? Now, if you are very clear about incident ray, then you will be as clear about objects. It is real object, it is virtual object, whatever is there. Similarly, when we talk about images, images is decided according to, this is point of intersection of reflected or refracted rays. So if you want to enter into the topic of object and image, you have to be very clear about incident ray and refracted ray. So object and image in ray optics are decided by rays, not by what we see generally is called object, we say, no, that is not the concept. So here we have to go into that. See that example also. See that example, that diagram there. This is human eye here. These are the eyes. And what are you looking on your eyes? You are viewing this, and that is image. This is the optical device. That is very important. Your eyes are also optical device only. This is optical device, and in optical device what you see is image. Here is object, but you are not looking at this. This is object. Now the question is, when you are not looking at the object, how you decided this is an object? So we are not deciding it. Incident rays are deciding it. That we have to understand. So object is decided by incident ray, and images are decided by reflected or refracted ray. So basic of object image, is that clear? Can we elaborate it further? Any question in this? Is this clear? Today 10th result, all the best to all of you for your 10th result. Tons of blessings and best wishes for your 10th result today, if it is there. Good luck, tons of blessings. All will you come with flying colors. Movie Plus, please ask once again. Movie Plus, please, I'm asking you to ask once again. You are my once again guy. All the best to all of you. God bless, God bless. My blessings too. God bless. You all will rock today. Okay, so we are starting this elaboration further. Object, please get this right, because I'm going on the further elaboration. What is object? Incident ray intersection. And what is image? Point of intersection of reflected or refracted ray. Okay. Now see this. Now we are going to discuss this topic. What is real object? What is virtual object? What does that mean? Real and real and virtual. How to decide that? We all have a little idea about that. On 10th level we have done this. That thing we will strengthen today. Conceptually we will discuss. But one thing, if I will write for you, who decides this? Real or virtual, who decides? So real and real or virtual objects or images are decided by optical device, that is must, not by the source. Optical device, not by the source of light. Please understand the line, and before understanding, read the lines. Not by the source of light. Source of light source of light may or may not be that object, because in my room some tube light is source of light, but I am looking at some other stuff, some wall I am looking at. So actual source of light is the tube light and I am looking at the wall. So source of light is not actually always, try to understand this line, source of light is not always deciding the object real or virtual behavior and image real or virtual behavior. Once I will give example, before that, that should be very clear in your mind. Who is the decider? Who is the decider, my dear students? Decider is optical device. Okay, what I mean to say, see one example. Suppose I am taking a plane mirror. This is the plane mirror. On this plane mirror, light rays are falling and these light rays are falling diverging. These light rays which are falling, first of all, if the rays come towards optical device, if rays come towards optical device, and this phenomena is called incidence. Incidence means we are talking about object. If the rays are coming towards optical device, then we are talking about incidence, and incidence is object. Reflection, refraction is image. So see this diagram and please look at the arrows. In this arrow, all these rays are coming towards the optical device. Optical device in this particular diagram we have taken as plane mirror. So that plane mirror is the optical device, and these light rays when falling on the optical device, they are diverging or converging. They are diverging or converging, everyone. Diverging or converging. Diverging, converging, diverging, converging. What are they? Answer I am asking. Look at this. Answer yes, 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 right. So what they are doing? Diverging. Good. Whenever light rays are diverging on optical instrument, that refers to a real object. Means we are talking about a real object. So try to understand the sequence. Who decides real object? Answer is real object is decided by the optical device. Mirror will decide, convex lens will, concave lens will, any optical device will decide the real object. Source will not decide. From where light is coming does not matter. So if on your optical device light rays falling, they are falling diverging rays. What rays? Diverging rays. Then you are saying that as a real object, because when you will try to coincide them, they will actually get coincided. They all are actually getting coincided here, and actual coincidence of incident ray actual coincidence of incident ray is called a real object. So the definition is very, very simple. What is the definition? Definition is, who decides real object? I will answer, optical device decides real object. Secondly, how we come to know it is real object? When optical device has diverging incidence, rays are going on optical device not in converging manner, diverging manner they are going, that is called real object. Understood? Clear? Okay. No, image I am not discussing right now. Just have discussion on object. Don't be so hurricane. Don't shift on images. There are other cases also for object. Now, my second example, and you will say, this is the optical device. This is the optical device, and on this, rays are, when rays are coming, rays are not coming diverging. Rather, rays on optical device are converging. When rays on optical device are converging like this, these rays are there like this. These rays are converging rays. Rays are falling on the optical device. Rays are falling on the optical device. Falling means we are talking about incidence. Incidence is there, and whenever incidence is there, I have written in the previous slide, point of intersection of incident ray, that is called object. So whenever there is an incidence, any kind of incidence is that we are discussing about object, there is no image coming into the picture. Try to understand. Incidence means object. Don't think image in your mind as of now. But tell me one thing, these light rays when coming on this, they are converging or diverging? Converging or diverging? When they are coming on this, you cannot say image here, because incident ray will not form image. For image you need reflected ray, you need refracted ray. So these rays are better incident on the optical device, and when here you will see like this, when they are meeting some point, that point will be what? Virtual object. What they will be? Virtual object. So this is called virtual object. Don't get confused this with the image. Why? Because when light is incidence, what is taking place? Ask yourself, in this question, reflection taking place or incidence? What is shown in the diagram? If you are getting answer as incidence, means you are talking about object, you are not talking about images. And when it is reflection or refraction, then we are talking about images. That's the very simple thing. So converging means virtual, diverging means real. And if I will ask this question, and that all of you have to answer. This is optical device, three cases are there. On this optical device, light rays are coming from infinity. Infinity means parallel light will come. Here, no convergence or divergence. No convergence or divergence. What you will say in this case? Tell me in this case, it is real or virtual? Diverging incidence, real object. Converging incidence, virtual object. Incidence means object. We will not even think about images. And when light rays are going parallel, neither divergence nor convergence, then what your answer will be? What you will say? What is this? Krishna, focus will be again after reflection. Why you guys are thinking reflection, refraction? That is the most number of confusing and silly mistakes students do. Incidence pe focus karo. Focus on incidence, not on reflection, not on refraction, because object is decided by incidence. Don't think the consequence. Tell me here, if light ray on this plane mirror are coming from infinity, then they are real or virtual, because they are not diverging, they are not converging. Real or virtual? Okay. Now the answer is real or virtual are not decided for object at infinity. Neither real nor virtual. So many of you have an idea that objects will be real or virtual. Get the third supplementary idea too. Because when rays are coming from infinity, real virtual cannot be decided, my dear students, because for real you have to have diverging. For virtual object, you have to have converging incident ray. When the rays are neither diverging nor converging, simple that question expect in your NEET coming, कि light rays are coming from infinity, the nature of object is real, virtual, neither, any. Your option will be neither, because we cannot decide the nature. Keep that in mind, okay? So when this is real or virtual, cannot be decided. Got this, everyone? So for real has to be diverging, for virtual virtual object has to be converging, neither diverging nor converging, neither real nor virtual. So now let me know for any beta, or I am taking plane mirror as an example. For any device, if light rays are coming from infinity, image nature you can decide real or virtual, object you cannot decide, okay, because sign plus minus nothing you can. Okay, now tell me, in object any problem is there? Three category I told you. Real object, have you understood? Virtual object, have you understood? And neither real nor virtual, have you understood? Tell me this, everyone. Image I am coming, image we have not discussed. Everyone, any doubt I am asking you, any doubt in this, please tell. Object have you got? Yes, nice. Don't say yes, you have to say thank you. Rian is saying once explain. Rian, very simple. 3 diagram is there for you on this box, on this screen. Please read these terms. Here, diverging rays, diverging incident rays, Rian. Then you will say real object. Converging incident ray, then you will say virtual object. And neither converging nor diverging parallel incident rays, then you will say neither real nor virtual, we cannot decide. But in all this, you have to have incident rays, you cannot have reflected or refracted. Reflected, refracted will be images, not object. If you have got this, I am asking you one question for this slide, a testing question. Ready, all of you? Testing question for this slide. My question is, whatever objects are present in our surroundings, whose images we are looking at. Please understand the question, everyone. My question is, whatever objects are present in surroundings, like you are in your room and many objects are there in the surrounding. You are not aware of the object, because when you look at it, you look at the images, you can't see an object, right? So these objects in our surroundings, they are real or virtual? Objects in our surroundings are real or virtual? Everyone, this is a question for you. Welcome all of you. Now my question. Okay, I'm so sorry for this, but that is the topic only. Tell me only, this is my question to all of you. Objects in our surroundings are real or virtual? Objects in our surroundings are? Thank you, thank you, thank you, thank you, thank you. Objects in our surroundings are real objects. Do keep in mind, objects in our surroundings, objects in our surroundings, objects in our surroundings are always real, real objects. They are not virtual, because suppose some lamp is there, that is the lamp, right? That is the lamp, and this lamp is sending, this is the object here. That lamp is sending light to this object, and from this object, when it will go on some optical device, it is going on some optical device. Here is the plane mirror. Here is the plane mirror. On this optical device, from the lamp, this is the source of light. That is the source. Light ray is going on some object. That is the object. From that object, light rays are going diverging. And on this plane mirror, diverging light will fall. When diverging light falls, from the previous slide, diverging rays means real object. So here we are talking about the real object. Got this? So whatever object is there in our surrounding, they are called real object, they are not virtual, and you see their images, the images are virtual, not the objects. So object you have to get it, because in ray optics when you will proceed further, maybe the definition seems to be boring, I understand, but when you will proceed in this ray optics, these terms becomes very, very important. Always in ray optics, one mistake kids are doing, the sign convention, because they are not identifying real and virtual. So this is a very simple trick. Diverging means real object, converging means virtual object, and neither converging nor diverging means no real and no virtual. That is the point. Okay. Now see, we can't see object better. Riyan, we are not looking at the object. We are not looking at the object, but objects are there. No, many things we don't see, we can't see, but they are present. No. So the point is this, कि we can't see, but we are looking, Riyan, at images. And if images are there better, object must be there. No, images are formed of some object only. So yes, we cannot see. By looking, by viewing, we cannot decide. But by concept, we can decide image is there. So object must be there. What is that object? That object is real object, because any object, because of irregularities, all surfaces are rough surfaces in our surrounding. And when light falls on a rough surface, it diverges. And that diverged light fall on optical device, plane mirror or anything. So when diverged light falls, that is called a real object. That's the point. Okay. Okay. Can we go to next? Thank you, Afia. Means a lot. Thank you, thank you, thank you. Okay. Now we are discussing next one. The point is virtual and real images. Now tune up your mind. What is images? Now when we talk about image, we are not concerned about incidence. Now we will focus on reflection. Now we will focus on refraction. So incidence part you have to cut if you are looking at images. Decide image by deciding the reflected and refracted rays. Don't indulge into incidence. So incidence part please cut from your mind and think reflection, think refraction if you want to think images. Now, case number 1, this is my optical device, right? That is an optical device. On this optical device, light should come from it. Light is not falling on it. Falling means incidence. And we are not talking about incidence here. What we are talking about is return. So light is returning from here. Please have a look. So light is returning from, when light is returning from this, like this way light is returning, and that return from this, is diverging or converging. Please have a look. First of all, for image, we have to have a returning light. Means who is giving you the light? Optical device is giving it, not taking the light. Taking means incidence, it is giving you back. When optical device is giving you back, then tell it is diverging or converging. Stop texting and see here. Now focus on this. Basics funda. Even if you know, it will be revision. It is diverging or converging. Diverging, because light ray are going spreaded in different direction. Divergence and convergence you have to understand. Convergence means they are going towards a point, and divergence means they are going away from a point. Okay. Now see. Here, if they are returning from the optical device, that is the device, and they are returning from the optical device in the diverging manner. What manner is there? Reflected light, diverging manner. Then it is called virtual image. Now you have to understand, because you will get confused if you are not getting it. I told you, diverging in real object, incident ray diverging, real object, but reflected rays diverging, virtual image. So diverging gives you virtual for image, diverging gives you real for object. Got this? Understand this. When light is coming from the mirror, light has to come from the mirror, and that is reflected. When it is getting reflected and it is diverging, that is called virtual image. Again, when we are looking at the convergence here, light is coming convergence, that is the optical device, and from here light rays are coming like this. These all are reflected rays. They are coming from the device. They are coming from the plane mirror. They are not coming, they are not going on the plane. They are returning back from the plane mirror. And when these lights will intersect, then this is called real image. Then they are saying real images. So real image means what should be that nature? That nature should be converging. So diverging reflected ray, I am writing this for you. Diverging reflected ray or refracted ray, that is your virtual image. That is your virtual image. And converging reflected ray, that is your real image. So keep that in mind. And again, if light rays are coming parallel means neither real nor virtual. We cannot decide. Any doubt in images, anyone? All the best to all of you for your result, but that is also being asked in NEET after 2 years. And that day also, if you want that all of the best, you have to learn today. So object and real, take my words, this is in ray optics is the most confusing thing. Always you will be struggling with the sign convention, always. That is the only doubts that is unanimous to all of the students. So please understand this, and this talking na result and this all, this will be good for sure for today, but after 2 years again one result will come, and for that we have to work today. Got it? So diverging and converging, I am summarizing very simply. Try to understand. Think in your mind object you are thinking, think incident ray. Diverging incident ray, real object. Converging incident ray, virtual object. No diverging, no converging, neither real nor virtual. Now come to image. When you are thinking image, think always about the rays coming from the optical device. Rays are coming from the mirror, from the lens. That is always reflected or refracted. Now here, if rays coming towards you are diverging, virtual image. Rays coming towards you are converging, real image. Got this? Neither converging nor diverging rays, reflected rays or refracted, neither real nor virtual. Understood? Done? No, but the conventions are not easy. Maybe up to 10th class they are easy. But since you will proceed in successive reflection, refraction, more than one element you will do, then it is not that easy. Easy but confusing. I am not saying it is difficult. But see, one more thing I am showing here. Please understand one thing. This is a plane mirror. All of you concentrate on it, because this is the question you guys have to solve. That question you guys have to solve. Please have a look. Light rays are going like this. Light rays are incident. These are the way light rays are falling on it. Can you tell me what we are talking here? It is real object, because incidence is there. We are talking about object. Real object or virtual object? That is my question to all of you. Real object or virtual object? Everyone. Image, Riyan. For ray optics, if I am looking at you, I will tell you are image, because I don't know, image is there, so object will be there, but I cannot see your object. I can see your image. This real or virtual? Okay. Go here, everyone, again see. For real object, what rays you need to have? You need to have diverging. Now see, are they converging rays or diverging rays? They are converging rays. They will converge at somewhere, at some position. Converging rays. It means we are talking about virtual object. We are talking about virtual object, because rays are converging. See, here only we are doing mistake. Converging rays means we are talking about virtual object. Got this? Converging rays means virtual object. Now, if I will place one more mirror here, here I am placing a mirror, one more device is here. Got this? Now this is device number 1, this is device number 2. What will happen to this device number 2? My question to all of you, virtual object for device number 1, device 1. Now what is this for device 2? For device 2, it is virtual object, real object, virtual image, real image. Tell me the nature of this ray on this, what it will be. For device 2, now see, you were saying that it is very easy. It is easy but confusing. Successive reflection, second device is also there. Now you have to say कि for device 2 it is real or virtual. Try to answer. Ishwar, I am not actually taking plane mirror today. I am just telling you object and image. Plane mirror, what happens? It is always from virtual. Yes, it is always from virtual. But for virtual image, your object should be real. If plane mirror, since you are asking, I am explaining it. But this question is due for you. Ishwar, this is for you. This is a plane mirror, right? And in plane mirror, light rays are incident like this. From wherever, light rays are incident like this. So from this point, it is reflected. From this point, beta, it is reflected. And here image is formed because at this point, two reflected rays are intersecting. Reflected rays intersection is called image. So here image is being formed. Now this image is actual intersection, so that will be obviously real image. And you are saying ki always virtual. There is nothing always. There is nothing always, Ishwar. You have to tell the nature of object to tell the nature of image, right? Yes, maybe you guys have studied a plane mirror for real object. And if you have studied for real object, obviously your images are virtual. But if I am studying this now, you can ask, how is this possible? That the question was. Suppose light ray is falling on this in this manner. So this is the real image. And if this is the real image, obviously virtual image is not always forming in the plane mirror. Real image means object was virtual. Object is virtual. Understand this one, right? So virtual object, real image, it is the answer. Ishwar, I think it is clear to you. So don't take anything for granted in physics. There's very many models and many exceptions, right? So now for this, I'm coming back to this question and we will discuss this again. And to discuss this again, I'm drawing the diagram and all the phenomena in a better way. See this. What happens if two mirrors are there? That we have to discuss. Okay, so focus on this. Gradually, topic become very interesting. This is one device. In this device, that is the plane mirror, right? In this plane mirror, if some light rays are falling like this, and I asked you, ki, what is this? And many of you answered correctly, ki, this is virtual object. That was the case, virtual object, because rays are converging. You don't have to decide anything else. Converging rays means object has to be virtual. But at this point, reflection will take place. At this point, reflection will take place, and this device 1 will form real image, I real image. Now this real image, if I am putting here another device number 2. Now for the plane mirror 2, for the device number 2, please understand, whatever image has been, this is called successive reflection. It means image of first is object of second. Image of first is object of second. Image of second is object of third, and it goes so on. So that is the real image for the device number 1. And this will be act like object for this. This will act like this is real image for 1, and this is object for second device. And this object for second device, if I will take the second device, rays are actually like this, because these rays are here, but this, if device 1 would not have been present, these rays were going like this, these rays were going like this. And on the second, it is what? Converging. On second also, it is what? Converging. So on second device, converging, but converging is what? Converging is virtual, because no rays are going there. So virtual rays, dotted lines means virtual rays are going. And if object will be virtual, image will be real only. So that's the point for second device. If you're not getting this, you try to get in this manner, very simple line manner. If for first device image is real, then second device, that real image will form virtual image. This is object for second. And what is that object? that object is real. So its image formed will be virtual. So for first, what image formed? Real. For second, what image will form? Virtual. If there is a confusion, let me write this for you separately. See, I am writing this for separately, try to understand. Successive reflection. Please understand, topics are like this. Successive reflection, we have to understand with open mind. In successive reflection, what happens? Image formed by first device, acts as an object acts as an object for second device, whatever device, a plane mirror or some other mirror. So first image formed by first, that is object for second, right? When I'm saying this is the first mirror and that first mirror has virtual object. Why virtual object? Because rays are converging, object has to be virtual. Then it will go here and it will form a real image. That is the real image. That real image is image of this. But if I will put another device here, for this device, this will act as an object. And since object is real, image will be virtual. So, Ishwar, answer of your question is, in plane mirror, object and images are of opposite nature. That is the correct concept, you have to rectify it. In plane mirror, object and images are of opposite nature. There is no fixation of it is virtual image always or it is a real image always. The nature will be opposite. Like here for first, object was virtual. What was object? Object was virtual. So I am saying image is real. But for second, this real image of first acts like object for second. And if the object is real, the image will be virtual. That you have to understand. So there is nothing like a fixed image virtual or fixed image real. Okay? Understood this, Ishwar, or any of you? This successive reflection. Okay, that big smile on your face. Nice. Okay, now any doubt in this, please ask. Can I prove the experiment by taking both plane mirrors? Of course you can. Sukesh, of course you can. But whenever you see, you will always see virtual image. You will see virtual image. Have you guys seen ghost ever? Have you guys seen movie plus? You are not seeing once again today. I am so overwhelmed today because I was expecting that once again from you. Too good here. Have you guys seen ghost? I am repeating. King of games, I am repeating. But let me ask one question. Ghost देखा है आप लोगों ने? Have you seen bhoot, ghost, anything? No? Or yes? No. Welcome, Krishna. Lens is different, beta. Lens today we are not discussing. Don't derail from the subject. Don't say yes because you cannot see. You are a science student. Don't say that you have seen ghost. You can only see virtual images of real object. Got this? And if ghost you can see, then entire concept of science will be Newton have to change all the laws. You saw in mobile. You come here, I will show you in campus also. Like you will see me, no. So don't say someone ki you have seen the ghost. You are a science student. If someone is telling you ki I saw the ghost, tell him ki shift your subject from commerce to science. Then you will come to know. Got it? Now movie plus, love you too. Once again, I was waiting for this. Exactly, they are not there. They are not, because they are not real object. You cannot see them. That is the point. Okay. Once again, thank you for asking once again movie plus. I was waiting for this one plus. So point is, I thought all of you get, I am writing this for you. In plane mirror, what happens? Since plane mirror, don't get this, plane mirror is tomorrow's topic. I am not discussing plane mirror today. I am just discussing image and object today. In plane mirror, since some of you have discussed it, object and images are of opposite nature. Opposite nature. Don't sit with a fixed mind ki image is always virtual. It is not like this. I hope this is clear. Okay. Now before this, plane mirror is the tomorrow's topic. So before that, we have to get a little about laws of reflection. But any doubt in object and image to anyone? Welcome. Welcome. My shirt is good. It is t-shirt, Kaushik. T-shirt is good. Thank you so much. Ghost player Kadu. Yeah, Telugu I don't understand. I'm looking handsome. Thank you, yeah. Like 2-3 days a week I look handsome, I know. On and off. Okay, so no doubt. So I'm going on laws of reflection. See this. All of you know that first law, I will start from the second law. Second law, first law, after this I will start. That is the more numerical and all of you must be aware. Angle I is equal to angle R. Means angle of incidence is equal to angle of reflection. Okay, that you must be knowing. On this, angle of incidence equal to angle of reflection. On this, I want to test you with some of the concepts. First question, example for all of you. This is the plane surface. On this plane surface, some light is falling. When some light is falling, obviously it will bounce back, and when it is bouncing back of light, that is called reflection. That is bouncing back. When it is bouncing back, I am saying it is reflection. I am saying this I and this is R. Tell me what is equal to what? Law of reflection, tell me in this question. I equal to R. Tell me what is equal to what? Explain law of reflection here. Explain law of reflection. Angle I equal to angle R. Explain me law of reflection here. Everyone. I am from Jupiter. Jupiter, you know. Hussain will accept your friend request. Nilavani, please see this, answer this question. Venkat Togodera, I always expect these correct answers from you. All subject corner, very good. You are also here to give right answers. Good, dear. Anyone? Angle of incidence is equal to angle of reflection. That is a law of reflection. According to that diagram, if I will say, always keep in mind that this I and this R, they are measured with normal. Normal to the incident surface. Normal means perpendicular. So that is the surface, right? And on this surface, if we are drawing a perpendicular, that line is called normal. This is perpendicular. When we are measuring angle of incidence, that is incident ray angle with the normal. That is the incidence angle. Wherever you see I, that I does not mean it is incidence angle. That angle has to be measured with normal. So if this is given I, that will be 90 minus I, because total angle is 90. And if I am explaining the law of reflection in this diagram, I will write 90 minus I equal to R. Just wanted to say you, don't just blindly jump on to I equal to R. That I and R, they have to be measured with the normal. That should be. Snell's law is refraction law, movie plus, not here. This is Newton's law. So this is first law of reflection, second law, which is obviously Newton's law, not Snell's law. Got that? So from where you will measure angle of incidence and angle of normal, anywhere in the refraction, reflection, anywhere the angle of rays are there, then angles are always measured with normal. Okay. Normal, I are present in same plane. That is the first law. I am coming on to this. Absolutely right. My second question to all of you, and this if you will answer, you will get my t-shirt if you are coming to this campus. Got it? This answer, if incident ray, refracted ray, the normal lies on this, exactly they lie on the same plane, to good of here. But my question to all of you, this is t-shirt question, if you can answer it. Ready? Question is, you can answer this in tomorrow class also. I am giving you 24 hours for that. Why angle I is equal to angle R? Why angle I is equal to angle R? Why not I equal to 2R? Why not I equal to R by 2? This is law given by Newton. There must be some observation made by him. So that is my question, ki why Newton, how he found that angle I is always equal to angle R? Moreover, why this is with normal only? Why not angle with surface I and angle with normal R. What made this conclusion? That is the t-shirt question for all of you. They are in the same plane at point of incidence. That is the first law. Yes, absolutely right. But this question answer, because they lie in the same plane. Sorry, Munni, but that's not the correct answer. Sinus is not coming here. Sin is coming in refraction. When a ray gets reflected from the plane, angle is equal to, yes, it is. But why? My question, please try to get. No, Ryan, sorry, that's the wrong answer. That's the wrong answer, wrong answer, wrong answer. I'm giving you 1 day time. Dikshita, law of reflection of light. Absolutely, but why is the question? And what is the first law, my dear students? First law that all of you already written. Incident ray, normal and reflected ray all lie in same plane. If you want to know physics, please try to know every why, because only knowing the fact does not make you a good student at physics, right? Absolute concept should be there. So that I will ask you tomorrow. According to Ishwar, you have googled it, but chalo, this proof I will give you tomorrow. You have googled y angle I equal to, or you know, I don't know, I am not saying you have googled it, I have not seen you googling it. Light always selects shortest path to reach the, yes, exactly, that is Fermat's principle. Chalo, even if you have googled or you have taken some other help, you have done some diligence here, and for that I am appreciating all of you. Okay, Fermat's principle I will tell you tomorrow. Y angle I equal to angle R, and we will do very interesting questions of plane mirror. Tomorrow is the day for plane mirror. Till the time, bye bye all of you. God bless. Bye bye. Take care.
Good morning, everyone. Good morning. Krishna, Afia, good morning. How are you, everyone? Animi Reddy, Aishwarya, hi Malikarjun, Krishna, good morning. Coco, Venkat, Navyashri, Ishwar, very, very good morning. Good morning, good morning. I'm doing very good. I hope all of you are also doing good and enjoying the classes. Are you guys enjoying the classes? Yes or no? If you are really enjoying the classes, I want all of you to hit the like button first, then we'll start the class. Thank you, Sarath. First, hit the like button. All of you, hit the like button, then we'll start the class. Yes. Happy Baisakhi. Today is Baisakhi. Thank you. Wish you the same. I didn't know. Okay. All right. If somebody is not enjoying the class, two things can happen. Either you can leave the class or I will make you understand the topic. It's your wish. Okay. All right. All right, Riyan. Thank you, Riyan. Let us start. So yesterday we had talked about limiting reagent. In the very first day that we did, which was lecture number 11, I discussed with you basic questions of stoichiometry. Where one reactant is given, other reactant can be asked. A reactant is given, a product can be asked. Then we went to lecture 12 where we have discussed limiting reagent related. Limiting reagent related. So in case if the data of all the reactants are given, then how do we reach to the amount of product formed? So one of the reactant might finish in between. How do you find the limiting reagent? What was the formula to find the limiting reagent? Everyone tell me. How will you find the limiting reagent? Chocolate questions we'll see. Chocolate question I'll tell you. First you tell me, how do you find the limiting reagent? What do we do? Yes, we do given moles by stoichiometry. Correct. Given moles by, not given weight by stoichiometry. Sairaj Surya. Given moles by stoichiometry. Never do given weight by stoichiometry. That will not give you correct answer. Given moles by stoichiometry. That's correct. So given moles by stoichiometry, yes, gives us the limiting reagent. We'll see the chocolate question. Today is lecture 13 and we are going to discuss percentage purity and percentage yield related question. That means if sometimes the reactant that we are using, it is not 100% pure, then how do you find the product? Or sometimes reaction is not able to complete properly, percentage yield related. Okay. Many times what happens is when you are doing the experiment, in between, let's say, some of the liquid spilled. So what will happen? Percentage yield of the reaction will go down. So sometimes reaction doesn't complete properly. Sometimes the reactant is not pure properly. Then there are some complications that we can get. Easy way to solve the question I will tell you today as well. Okay. Akhil, later you can ask these doubts. Now let us start with the yesterday's chocolate question. Okay. Yesterday's chocolate question that we did was this one. Okay. All of you can see here. I will solve it for you. They are saying 30 liter of each N2 and 30 liter of H2 gas are taken at STP and they are reacting to give ammonia gas. They are reacting to give ammonia gas. Let's do the reaction. Reaction would occur like this, as all of you know. N2 gas reacts with H2 gas to give ammonia gas. Okay. We'll balance it by saying 2 ammonia, 3 hydrogen. So stoichiometry become 1, 3, 2. 1, 3, 2. Okay. Now, what is given to us? Volume is given. 30 liter of each. Volume is given. Volume of nitrogen is given 30 liter. Volume of hydrogen is given 30 liter. Okay. Now, from volume we can find the moles. Moles of nitrogen. We know the formula. It is volume by 22.4. Moles of hydrogen is also volume by 22.4. So I'll find the limiting reagent. I'll do given moles by stoichiometry. Given moles by stoichiometry. So I'll get 30 by 22.4 divided by 1. Stoichiometry is 1. I'll do 30 by 22.4 divided by 3. Divided by 3. And we can see here that this number is small. This is 30 by 22.4. It is 30 by 66 around. This is small number, so this is the limiting reagent. That means hydrogen will decide. Hydrogen is going to decide. Okay. Hydrogen will decide how much product will form. So first of all, answer for the first comes out to be, which is limiting reagent? H2. I hope most of you got it correct. I hope most of you got it correct. Why 1 by 3? Because Here hydrogen, there is stoichiometry of 3 beta. Okay, stoichiometry of hydrogen is 3. So that's why we have done given moles by stoichiometry to find the limiting reagent. Yesterday's class you should have attempted. Okay, I hope all of you got this answer correct. Volume of excess reagent remaining. That means they are asking how much N2 is unreacted. How much N2 is unreacted? How do we find it? All of you see here. We started with, initially we had 30 liter nitrogen, we had 30 liter hydrogen, we had 0 liter ammonia. This was the initial scenario. Finally, when you reach, we know that hydrogen will become 0 because it is the limiting reagent. Hydrogen is the limiting reagent. We know it is going to finish. How much nitrogen will finish? Let us find out. See the reaction. 3 mole hydrogen reacts with 1 mole nitrogen. 3 mole hydrogen reacts with 1 mole nitrogen. I can say 3 mole hydrogen react with 1 mole nitrogen. Or I can say 3 mole hydrogen consumes 1 mole nitrogen. Okay. So I am checking that 30 liter will consume how many liter? 3 mole hydrogen, I can say 3 times 22.4 liter. This much hydrogen gas consumes 22.4 liter nitrogen gas. So we'll say 1 liter hydrogen gas, when it will finish, it will consume 22.4 by 3 times 22.4. Unitary method, this comes down, cancels out, 1 by 3 liter. So 1 liter hydrogen consumes 1 by 3 liter of nitrogen, and 30 liter hydrogen, which will completely finish because it is the limiting reagent, it is going to consume 1 by 3 times 30 liter nitrogen. That means it consumes 10 liter nitrogen. So 10 liter nitrogen is reacted. Is it clear to everyone? 10 liter nitrogen is reacted. Yes, 20 liter wasted means 20 liter remaining. 10 liter has reacted. Is it clear to everyone? Yes, good. So 10 liter has reacted. So when I take nitrogen, out of 30 liter, 10 liter is gone. So 20 liter is remaining. 20 liter nitrogen remaining. 20 liter nitrogen remaining. Good. Good. All right. Then next question is, find the volume of ammonia formed. Find the volume of ammonia formed. Find the volume of ammonia formed. Now we'll again go back to the question. Now you see, we can see here that when 3 hydrogens react, because we told that everything will be decided by the limiting reagent. Hydrogen says when I react 3, I will form 2 ammonia. So we'll say 3 times 22.4 liter hydrogen produce 2 mole ammonia, means 2 times 22.4 liter ammonia. Okay. 3 times 22.4 liter hydrogen means 3 mole hydrogen produce 2 mole ammonia. So 1 liter will produce how much? 1 liter hydrogen will produce how much? 2 times 22.4 by this number, 3 times 22.4, which is 2 by 3 liter. But we had how much hydrogen? We have consumed 30 liter hydrogen. So we'll say 30 liters of hydrogen will produce 2 by 3 times 30, which is 20 liter ammonia. 20 liter ammonia. Good. Very good. 20 liter ammonia. That means ammonia has produced 20 liter. So finally we get 20 liter ammonia. So final volume is how much? 40 liter. Final volume is 40 liter. If you, those of the guys who are trying to disturb us, first of all, you are not doing any good to yourself, not doing any good to your parents. Your parents are spending so much money on you. Please have respect to your parents. Please have respect to you, to your teachers. You might not be even science student, you might not be even 11th class student, but still you are wasting your time, no? What good does it do to disturb a class? It does nothing good. If you are from some other subject, go study your subject. Okay? Please, it's a request to you. Okay? Only if you give respect, you gain the respect. Only if you give respect to others. That's what your parents also tell to you, no? When you are fighting with your small sister or small brother, if you give respect to your small sister or small brother, they will also talk to you respectfully. Bhaiya, do this. Behna, sister, do this. Akka, do this. Otherwise, they will also start abusing you. It's the same around with everyone. Okay? So, yes. So, final volume is 20 plus 20, 40 liter. So, the question was, how much is ammonia formed? Answer is 20 liter ammonia formed. And how much is the total volume of final mixture, which is 20 liter plus 20 liter? 40 liter. Because it's a chocolate question, it's a little long question. I hope everybody is clear with it. I hope everybody is clear with it. Just say a yes. I need a lot of yeses to know that it's clear to everyone. Alright, good. Please listen to this class again in the evening. Yesterday's class also, today's class also. Just for the chemistry I am saying. I don't know how much difficult topics are going on in physics and other subjects. But this topic in chemistry is difficult. And if you're understanding, it's very good. If you're understanding, it's very good. Okay, so this is the chocolate question. I hope all of you have solved it. How many of you got all answer correct? 20, 20, 40. How many of you all got correct answer? Just write I got. Just write I got. If you got all correct answers yesterday yourself. Good, Supraja, Ishwar, Chakri, Senpai, good. Alright, that's good. Now today we'll do the next type. All of you listen carefully, keep your hands away from the keyboard. Keep your hands away from the keyboard. Alright, all of you see here. Next topic today, very important topic. All of you keep your hands away from the keyboard for next 5 minutes. Understand this topic. Percentage purity or percentage yield related problems. Here just one extra step I have to put. These are basic questions only. How we did the first type of question, they are also the same. Just one little twist at the end. First you understand how do we get the answer, how do we correct the answer. Okay, how do we correct the, here we have to do a little bit of correction. Solve the question normally and then we have to correct the answer. Please see here. All of you. Study is a reactant. Study time. Study time is a reactant. More you study, you get better marks. Marks is a product. More you study, more marks you get. Right? Now let me give you the stoichiometry. Stoichiometry is that when I study for 10 hours, I get 200 marks. Okay, that is the stoichiometry. 10 hours give 200 marks. This is when everything is fine, 100% efficiency. When you are actually studying for 10 hours properly, with your eyes open, with the books also fine, everything is good, you are studying for 10 hours, you get 200 marks. Now, the question comes, all of you, think and answer properly. If you are studying for 10 hours, okay, the question is, if you are studying for 10 hours, but only with 50% efficiency, that means only 50% of the time you are awake. Rest 50% of the time you are sleeping. How much marks will you get? How much marks will you get? Tell me. Very good. Isn't that very simple? Only how much marks you will get? 100 marks. We will get 100 marks. So what is happening here is, actually, due to any problem in efficiency, product decreases. Can you remember this now? Product decreases. product decreases. Can I say always product will decrease? Whenever there will be a problem in efficiency, whenever reaction is not able to occur properly, whenever you are not studying with 100% purity, then your marks will decrease. Means product will always decrease. Yes, product will always decrease. So remember it, product always decreases. Just say this to yourself. Whenever there is a percentage problem, I will decrease the product. I will decrease the product. How do you decrease the product? How do you decrease the product? You find the product theoretically and then multiply by percentage given. Multiply by percentage given. So, if you study for 10 hours, you should have got 200 marks. So, 200 is your theoretical number. Theoretical marks. That if everything was fine, product should have been 200 marks. But then I will multiply by 50%. 50% into 200 automatically become 100%. Formula becomes, remember it, product actual. Remember this formula and write it down. Product actual is always less than product theoretical. And product actual equal to theoretical product into percentage given by 100. Remember the formula. Just multiply by percentage, automatically answer will go down. Okay. Multiply with the percentage, automatically answer will go down. So I'll first do the question normally. I will not look at the percentage. Okay. I will not even look at what percentage is given. I will do the reaction normally, thinking that percentage is not given to us. Everything is fine. I'll find the answer. Then I will decrease the answer by multiplying by percentage. This much. Okay. All right. This much you should remember right now. And now let us talk about the reactant. All of you see here? All of you see here? Again, I am asking the same question. This time, I want to get 200 marks. I want to get 200 marks. I am studying with 50% efficiency. How many hours should I study? How many hours should I study? Tell me. How many hours should I study? Being 50% efficient person, how many hours should I study? 20 hours. 20 hours is correct. Most of you are giving the correct answer. These are very simple question I'm asking, okay? 20 hours. Yes. So with 50% efficiency, you will say half time I will sleep, half time I will be awake. To get 100 marks, I need proper study for 10 hours. So if I only study for 10 hours because there is 50% efficiency, I will get only half the marks. So instead of 200, I will get only 100 marks. So I have to study for double time. I have to study for double time. So I have to study for 20 hours. 20 hours to get 200 marks. Yes, 20 hours. Can you see that reactant has to increase? Reactant has to increase. Normally, you should study 10 hours only. But when there is a problem of efficiency, you have to increase the reactant. Can I say yes or no? Can I say this yes or no? Whenever there is a percentage problem, just remember it now. Reactant has to increase. Reactant will be more than expected. Reactant must be taken more than expected. Product will be formed less than expected. Yes. Okay. All right. So the formula becomes second formula. Remember it. So product has to be less than theoretical, whereas reactant, actual reactant, should be taken more than theoretical. Reactant has to be taken more than theoretical. Okay. So, in order to increase reactant, what do? You divide by percentage. You divide by percentage. You thought, sir, 10 hours should give me 200 marks, but now efficiency is 50%. Let me increase my time. How to increase your time? Divide by 50%. divide by 50%. Automatically it will become 20 hours. Time will increase. So divide by percent or multiply by percent depends on what you are asking. If they are asking product find, you multiply by percentage, decrease the product. When they are asking how much reactant required, you divide by percentage, reactant will automatically increase. So actual reactant is theoretical reactant divide by percentage into 100. So you will divide by percentage here. In the question, it will be more clear what we are doing. This is just a small experiment that I told you. Okay. If you want to get, what's the problem? People who are commenting things which are not related to the class, you're wasting your time, wasting your life, bache. I feel sad for you. Okay. I don't feel angry. Madhu, Ravi Teja, Charan Merka, you guys will come here. Siddhu, King of Rock, you guys are going to come here and join. Hai na? Is this how you behave in your home also? Siddhu Rock, Vaishu, is this the way you guys behave at your home also? Okay. You might be feeling that all the teachers are so jolly, they are all very funny. No teacher is like that. Don't take the advantage of it. Okay. Whenever it is required to scold you, slap you, everything will do. Okay. So don't feel like you can talk anything over here in the chat. Stop chatting, understand. It's a difficult topic. Then tomorrow you will say that I'm not understanding anything. Okay. Switch off the chats. Will they be able to see chats? If you switch off, let them do. Okay. All right. So reactant has to increase, product has to decrease. So just keep one thing in mind and write it in your notes as well. Whenever you see percentage type question, I will decrease the product. Remember it. You will just say yourself, I will decrease the product by multiplying with percentage. Okay. I will decrease the product by multiplying with percentage. And whenever they are asking reactant, you say, I will increase the reactant by dividing with percentage. That's all. Finished. Now you can solve any number of questions. First two I will do, rest you will do. I hope all of you are ready to do. First two I will do. I will not let you chat till the time I do first two questions. Then I will ask you to do yourself. Okay. All right. I will decrease the product by multiplying with percentage. I will increase the reactant by dividing with percentage. Just keep saying this to yourself. Keep saying this to yourself. Say it 10 times, all of you. If you say it 10 times, you'll never do mistake. Whenever they're asking product, I will decrease the product by multiplying with the percentage. I will increase the reactant by dividing with the percentage. First question. All of you see here. Question is, calculate the mass of CO2 gas produced by heating 10 grams of CaCO3, which is 40% pure. Okay. How to deal with such questions? Step 1, get theoretical product. Find the theoretical product. You think that there is no percentage purity given. You think like that. Nothing is given to us. Everything is perfectly fine. We will find the theoretical answer first. So get the theoretical answer. So reaction is CaCO3 on heating gives CaO solid plus CO2 gas. Okay, plus CO2 gas. First I am finding theoretical answer. That means I want to think how much mass of CO2 gas can be produced by heating 10 grams of CaCO3. That I am finding. I am thinking that purity is not given, percentage yield is not given. Okay, so I will think that if everything is fine, then 1 mole gives 1 mole and 1 mole. When I put the molar mass, I can say 100 grams gives 44 gram CO2. 100 gram CaCO3 produces 44 gram CO2 gas. But they are asking for 10 gram. So we'll say 10 gram CaCO3 produces, obviously 100 produces 44, so 10 produce 4.4 gram CO2. But this is not our answer. This is theoretical answer. Okay, this is not the answer. It is theoretical answer. But we know CO2 is a product here. Then you say, I will decrease the product. I will decrease the product. So multiply with the percentage. Percentage is given 40%. So answer is CO2 produced will be 40% of 4.4. 40% of 4.4. This will be the final answer. Okay, multiply 40 into 4.4. You will get 1.76 grams. That is the answer. Okay, I am showing you what actually happened here. I am showing you what actually happened here. Overall, what happened? One, the way to do the question I just told. You think percentage is not given. You think percentage is not given to you. Do the question normally. Okay. If product is asked, decrease the product by multiplying with the percentage. 40% was given here. I multiplied with 40%. I got 1.76. What is actually happening here is, see this. This is what is actually happening here. What actually happened here is, I took 10 gram of CaCO3, but only 40% was pure in it. I took 10 gram of sample, which is 40% pure. Means out of 10 gram bacche, only 4 gram was CaCO3. Only 4 gram was CaCO3. Rest 6 gram was just sand particle. That means it was something else. It was not CaCO3, it was some impurity. Let me call it sand. That means in this, there is out of 10 gram, 6 gram sand was there and 4 gram CaCO3 was there. That is what I am saying. Okay. So actually CO2 will be given by CaCO3 only, na beta. This will decompose. So actually 4 gram CaCO3 gives how much CO2 is the question. That is the actual question if I go by unitary method. I am not using any formula. I said 10 gram I took, out of it 40% means 4 gram was pure, then 4 gram gives how much CO2 is the question. We say 100 gram CaCO3 from the stoichiometry gives 44 gram CO2. Then 1 gram will give 44 by 100. 4 gram will give 44 by 100 into 4, which is 1.76 gram. Okay, you might say this is easier to solve, but many times you will have to do it fast. So I would just suggest you do the question without the percentage, later multiply by percentage to decrease the product, divide by percentage to increase the reactant. One more question I will show you where reactant will be asked. Okay, then I will ask you whether it is clear or not clear. Okay, all of you see the next one. Question goes like this. What mass of 50% pure? I will first ignore it. What mass of 50% pure KClO3 must be heated to obtain 33.6 liter of oxygen gas at STP? So what is the reaction? First I'm thinking KClO3, which is potassium chlorate. You remember this reaction now. Okay, they will give the reaction in the question. KClO3 actually on heating gives KCl plus O2. This is the reaction. Okay, reaction is given to you. Now, we'll first balance it by saying that 3 oxygen, 2 oxygen, I'll make it 3, 6 oxygen, I'll make it 2 times. So I'll write 2 KCl. Balancing done. 2, 2, 3. That is the stoichiometry. 2 mole, 2 mole, 3 mole. Okay, 2 mole, 2 mole, 3 mole. Then convert it to mass data. KClO3. Potassium's atomic mass number is 39. So 39 is the molar mass of potassium. Chlorine is actually 35.5. Oxygen is actually 16, as all of us know. Okay. These three values you should remember only. Slowly, when you are solving more questions, they will come and you should be able to learn them. So KClO3, when you add them, the molar mass of KClO3 comes 122.5. When you add them, no, it will come 122.5. 122.5. 2 mole means 2 times 122.5 gram KClO3 produces 3 mole oxygen. I am talking about volume. So I'll just write 3 mole means 3 times 22.4 liter oxygen. Okay. I'm comparing the weight data of KClO3 with the volume data of oxygen. Weight data, volume data. Doing the question normally, thinking that no purity is given, how much KClO3 is heated to produce this much liter of oxygen? All of you can do. These many liter of oxygen come from 2 into 122.5 gram KClO3. So I will say from the stoichiometry, 3 times 22.4 liter oxygen is produced by using 2 times 122.5. So I'll write same only 2 times 122.5 gram KClO3. When everything is perfectly fine, 100% everything is going fine. So 1 liter oxygen should come from how much? 2 times 2 times 122.5 gram by 3 times 22.4. These many grams. So 33.6 liter. 33.6 liter oxygen should come from this value multiplied by 33.6, these many grams KClO3. This is not the answer, it is the theoretical answer. So what is the theoretical answer? Let us find out. On the table of 22.4, so this will go on the table of 11, it will go at 2, it will go at 3. 2 and 2 cancel out, 3 and 3 cancel out. 122.5 gram. 122.5 gram KClO3. But this is not our answer. This is theoretical. This is theoretical. Okay. Now, whether I should take more amount or I should take less amount is the next concern. For that, you can see KClO3 is our reactant. KClO3 is our reactant, and you already told that I will increase the reactant. I will increase the reactant. Okay. So, I will increase the reactant by dividing. So now you see 50% pure, 50% pure, okay, 50% pure. So you have to take more amount. How much more amount? Let us see. So we'll get KClO3 actual taken should be theoretical KClO3 122.5 gram divided by percentage into 100, which is going to be 122.5 by 50%, which will be double of it, 245 gram. This is the answer. 245 gram. This is the answer. I had to take double the amount. I had to take double the amount. Okay. I have to take double the amount. Again, I'm saying, all of you listen carefully again. It's a simple question. Very simple question. You don't look at the percentage given. How much KClO3 is required to produce this much O2? Okay. How much KClO3 is required to produce this much O2? You found out that I need 122.5 gram KClO3. How much I need? 122.5 gram KClO3. Now they are saying you are taking a 50% pure sample. That means if I take this much sample, in it only half of it will be KClO3. This is KClO3. Rest half sand will also be there. Half sand will also be there. So just now you found out that I need 122.5 gram pure KClO3. If I need 122.5 of this, then there will be 122.5 gram of sand also available. That means total solution or total mixture that I have to take has to be 245 gram mixture. When I heat it, sand will not get heated, it will not do anything. Just the KClO3 will produce the 33.6 liter oxygen. So I don't have to start with 122.5 gram, I have to start with double the amount. You have to double the amount of study to get same number of marks. Double the amount of study. Okay? If you study for 10 hours, but you will get half the marks. So product has to become half, but study time has to double up. I hope it is clear. Now I'll just own the chat. Just tell me if it is clear to everyone. Just tell me if it is clear to everyone. I have taken a lot of time to discuss one question. Good. Now, do you want to solve one question, all of you? Will you do yourself now? Yes. All right. Good. Good, everyone. All right. Good. I am happy that it is clear to everyone. Now, I hope you will do the question nicely. Okay. All right. Do this, all of you. Try this. Take your time. Take your time and do quickly. Jyoti, please watch the video again, beta, in the evening time. Right now, time is over. Just one question. This one I will discuss. Okay. But please watch this video once again. It's a little difficult topic, as I told you. Okay. But once you understand, no, you'll never do mistake. The only understanding is that I need to decrease product. I need to increase reactant. That's all. Try this. Net is gone. Working. Okay. Jyoti, beta, you'll have to watch the video once again, Jyoti. I am seeing your messages, Jyoti. I understand. It can take time. Watch the video once again, Jyoti. Evening time, 45 minutes. Give it time. NEET preparation is not that easy that in one go you will understand everything. Okay. We will try our best. You should also try your best. Give proper time. I'm getting few answers. Jaya Charan saying 70.4. 89.5. Tanmaya. $35.5 all subject corner. $44 Jai Surya. Kaushik Kumar 89. Manisha 89. Riyan 89. Sai 89. Okay. Kuchipudi Ratna. Ratna says 35. Sai Surya 44. All right. I'll see the rest of the answers later then. Tejaswini says 22. Can I call you Teju, Tejaswini? Tejaswini says this. Navdeep says, Venkat says 89. I couldn't see the chats much. Okay. Okay. All right. Now see the answer. All of you, see the answer. No problem. Now I will solve. You see the answer. All of you quickly see here. Then let us see who will get the correct answer. Volume of CO2 produced. CO2 is a product here. So I will decrease the product. Combustion of 32 grams of methane at STP if reaction is 80% efficient. Only 80% of the reaction is able to take place. So product will be produced less than expected. I will write CH4O2 CO2 H2O. Balance. 1 carbon, 1 carbon. 4 hydrogen multiply by 2. 4 oxygen multiplied by 2. Writing the mole data. 1 mole, 2 mole, 1 mole, 2 mole. All right. Now, 1 mole, 2 mole, 1 mole, 2 mole. 1 mole means 16 gram. 1 mole means they are talking about mass or volume. Volume they are asking. Volume. 1 mole means 22.4 liter. All right. What is known? What is unknown? Mass of CH4 is known. I'll keep it on left hand side. Volume of CO2 is asked. I'll keep it on right hand side. First, let me do the reaction normally. 100% efficient. 100% efficient. In that case, 16 gram gives 22.4 liter. 32 grams of methane would produce double of it, 44.8 liter. This is not our answer. This is not our final answer. You say CO2 is a product. I will decrease the product. I will decrease the product. Why you guys have increased the product? 35 is correct answer. Good. So I chose 38. Okay, Venkat, 35.8. All right, good. Those who chose 35.8, it is correct. Beta, reaction is not able to occur properly. Only 40% reaction is occurring. Because of 40% or how much? 80%. How much I gave? 80%. Only 80% reaction is occurring. That means out of 10 hours, you slept for 20%. That means you will get less marks, no? You will get less marks. You will get less CO2. You will get less CO2. So actual CO2 will be less. So I will decrease the product by multiplying with percentage. By multiplying with percentage, 44.8 into 80%, which will be 35.8 liter only. Not 89, Pratap Reddy, every time. I forgot to do the next step. Yes, Sai Surya. Is it clear now? Not 89, bache. Bilwakshi. Not 89. Whenever they are asking, find the product, you should decrease the product. How many times should I say? Whenever they are asking, find the reactant, you should increase the reactant. How many times should I say? Tell me, how do we decrease the product? Quickly answer. How to decrease the product? How to decrease the product? Tell me. Good, Nazia Sheikh, good. How to decrease the product? Multiply with percentage. Multiply. Yes. How to increase the reactant? Second question. How to increase the reactant? Mallikarjun, no problem. Do slow. That's why I say, yes, divide with percentage. To increase, divide. To decrease, multiply. Very good. Homework question. If you want to try right now, you have a break time, but no problem. You can, what do you say? Sacrifice your break. Sacrifice your break, get this answer quickly. Sacrifice the break, get this answer. Now, in this, yes, I am Punjabi only. You told 35, that's good, Neelavani. Now, in this question, you will say, sir, percentage is not given. We have to find the percentage. We have to find the percentage. Okay. Okay. Good. If you have said 36, it's good. Now, how to find the percentage? It's very simple. 20 grams of MgCO3 they are breaking, and you are getting 4.4 grams of CO2 gas. You are getting 4.4 grams of CO2 gas. Then how much of MgCO3 is pure? How much of MgCO3 is pure? You think like this. You think like this. Everybody think like this. This is the MgCO3 sample in which some sand is there, some MgCO3 is there. Some amount of sand is there. Rest amount of MgCO3 is there. One thing you all know that all CO2 will come from here only. All CO2 will come only from MgCO3. Sand will not give CO2. So you think 4.4 gram CO2 comes from how much MgCO3? That is pure MgCO3. Then find the percentage. Okay. 84% is बच्चे 84% is not correct. Jai Surya, just one last step you have done wrong. Jai Surya, Sairaj Surya. Okay, think yourself about it. Answer is 42%. Answer is 42%. This is the reaction. Magnesium molar mass is 24 gram. 24 gram plus 12 gram plus 48 gram, which is 84 gram. 84 gram produce 44 gram CO2. 84 gram MgCO3 produces 44 gram CO2. So we'll say 4.4 gram CO2 will be produced by 8.4 gram of MgCO3. This is pure MgCO3. That means out of total 20 gram of the mixture, beta, this mixture was 20 gram. This was 20 gram mixture. Now in this 20 gram mixture, I just came to know that 8.4 gram is MgCO3. It contains 8.4 gram MgCO3, rest sand. That means the purity of this mixture is percentage purity is 8.4 gram MgCO3 by total 20 gram into 100. So it is 42%. Good. All right. Please watch this video once again. I hope all of you will watch this video once again and understand this complex topic nicely. Good. Thank you very much. Bye bye. Take care. I will see you all in the next class. Bye bye.
Hi students, hello, good morning. Today's our botany class is development of female gametophyte and structure of female gametophyte. Another name of the female gametophyte is an embryo sac. Before going to the today class, a brief preview about the last class or previous class. First of all, give answer for this question. Read carefully. Assertion and reason type question. Wheat, paddy, grains and mango are example for single seeded fruits. First assertion statement is a true or false. The statement assertion is a true or false. Wheat, paddy and mango are example for single seeded fruits. This statement is a true. Second statement or only one ovule in each ovary. Only one ovule is present in each ovary of the plants like wheat, paddy and mango. And assertion explained by reason. Reason explains assertion. Reason for presence of single seed in each fruit, presence of single ovule in each ovary. Okay, then our right answer is the right answer is first option. Both the statements are true and reason correct explanation. Right answer first option. Already you learn about these concepts in last class. Monocot members, wheat, paddy, a dicot member, mango. In every fruit only one seed is there. Reason for this kind of arrangement, single ovule present in each ovary. Whereas in papaya and watermelons and orchids, number of seeds are many in each fruit. Reason, number of ovules also many in each ovary. Before fertilization, this is the ovary, it is the ovule. After the fertilization, ovary becomes as a fruit and ovules develops into seeds. Next, megaspore is also covered in last class. The process of formation of megaspores from megaspore mother cells. The short name of megaspore mother cell is the MMC or MESMC. Both are similar words. Full form megaspore mother cell is the first cell for the development of megaspores. Inside of the ovule is known as megasporogenesis. Megasporogenesis. What is the site of the microsporogenesis? Anther or pollen sac present in anther. What is the site of megasporogenesis? Ovule. Ovule is the site or placement for development of megaspores. Within the ovule, for example, the ovule, micropylar area and integuments. They may be either 2 or 1. Stalk, hilum, integuments. The bulkiest part of this ovule is the nucellus tissue. Nucellus, not nucleus. Spelling is different from nucleus to nucellus. Nucellus, nucellus. Deep within this nuclear tissue, towards the micropylar area, just only one cell is modified into MMC. What is the first form of MMC? Megaspore mother cell. This is the megaspore mother cell, is the first cell for the development of megaspores. This is the megaspore mother cell. Several lakhs or millions of nucellus cells are there. Among these many nucellus cells, only one cell is modified. It has a dense cytoplasm and a big conspicuous nucleus. In each megaspore mother cell, cytoplasm is the thick means dense, and a large conspicuous big nucleus is present. MMC is a large cell containing thick cytoplasm and conspicuous means clearly visible larger nucleus. What kind of cell division occurs in megaspore mother cells? Meiotic. Another name of meiotic cell division is the reductional division. It is also another important. Name the cells of a ovule that are able to perform meiotic cell division. Name a cell of ovule that is able to perform meiotic cell division. Megaspore mother cell. This megaspore mother cell able to perform meiotic cell division. Meiosis may complete into two stages. The first phase of meiosis is called meiosis 1, M1. As a result of the meiosis 1, a diploid cell is formed. Megaspore consisting of two nuclei as a result of first meiosis or first phase of the meiosis. Then two-celled structure is formed. The name of the two-cell structure is the dyad. DYAD. Dyad means two cellular structure. After that, both the nucleus of this dyad undergoes second phase of meiosis. M2 means second meiosis. Give rise to 4 nucleus and 4 cells. This is the megaspore. At this stage is called megaspore tetrad. Okay. Megaspore dyad is the result of meiosis 1 in megaspore mother cell. Megaspore tetrad is the result of meiosis 2 in dyad. Dyad become as a tetrad by the meiosis 2. How many cells are present in a tetrad? 4 cells. For every one is a haploid. All are present in linear row. Hence it is also called as megaspore linear tetrad. Megaspore linear tetrad. But finally, out of these 4 cells, 3 megaspores degenerates, but only one is the functional. Out of these 4, 3 degenerated. Only one is the functional. Finally, we can say how many functional megaspores obtained from each megaspore mother cell? Only one. Each megaspore mother cell can yield single functional megaspore. Megasporogenesis completed. Next small subtopic is development of female gametophyte. Another name of female gametophyte is embryo sac. In angiosperms, other name of the female gametophyte is embryo sac. Another name of male gametophyte is the germinating pollen grain. Germinating pollen grain is another name of male gametophyte. Embryo sac is another name of female gametophyte. Give answer for one question. What is the first cell for development of male gametophyte? What is the first cell for development of male gametophyte? Answer. For male gametophyte, the first cell, microspore. These older microspores are called pollen grains. Likewise, one more question. What is the first cell for the development of female gametophyte? What is the first cell for the development of female gametophyte? Single functional megaspore. But it should be functional. Out of 4 megaspores of a tetrad, only one is a functional. The single functional megaspore is the first cell for development of an embryo sac or female gametophyte. Note down this question, is very, very important. Ovule is not a first cell. Inside of ovule, nucellus is there. Inside of nucellus, one cell modified into megaspore mother cell. After meiosis, that megaspore give rise to one functional megaspore. This is the megaspore, is the first cell for embryo sac or female gametophyte. Yes, megaspore is the first cell for development of female gametophyte. No, MMC is the wrong answer. MMC is the first cell for development of megaspores. Next, in majority of the flowering plants, one of the megaspore is the functional, while other three degenerates. Just recently you learned, only one functional megaspore acts as a mother cell for the development of female gametophyte. Only one cell out of four act as a first cell or mother cell for development of female gametophyte. And here one more important concept. The process of development of an embryo sac. The process of development of an embryo sac. Embryo sac from single functional megaspore is also called as the monosporic development. Mono, single. Megaspore involved in development of entire embryo sac. Out of four cells, only one is involved, and this kind of development is also called as monosporic type. Monosporic type. It is one of the sources to construct different types of assertion and reason questions. Development of embryo sac is generally monosporic. Assertion, reason. This is a multicellular embryo sac obtained from single megaspore. Observe here. I'll explain the detailed account of embryo sac development or female gametophyte development. One degenerated, second, third degenerated megaspores. It is the functional megaspore. The name of the cell is functional megaspore. It has single nucleus. After one mitotic cell division, it gives rise to two daughter cells. Hence, this is the megaspore is called as bicelled or binucleated megaspore. At the beginning, this is the single cell consisting of only nucleus. As a result of the mitosis, it gives rise to two daughter nuclei. Both are twins, obtained from one common mother by the single mitotic division. Likewise, three mitotic generations successively occurs one after another one. In second generation also, this nuclei give rise to two daughters. It is also give rise to another two daughters. Finally, we can get four nucleated megaspore. Four nucleated megaspores. We can make one question here. How many mitotic divisions are required to yield four nucleated megaspore? Two mitotic generation. This is the first mitotic generation. It is the second mitotic generation. As a result of the first mitotic generation, two nucleated megaspore is formed. After the second mitotic generation, it gives rise to four nucleated. Then we can guess or expect. After the third mitotic generation, how many nuclei are possible to present in this megaspore? Guess, predict. How many nuclei are possible to present in this megaspore at the end of the third mitotic generation? This is the second generation, this is the first generation. At the end of the first generation, binucleated. Second generation, tetranucleated. Third generation end. Yes, good. 8 nucleated. These are the 8 nucleus. These 4 are daughters of these 2 nuclei. These 4 are daughter nucleus of these 2. To yield 8 nucleated megaspore. 8 nucleated megaspore, means a megaspore with 8 nucleus. How many mitotic generations are required? How many number of mitotic generations are needed to form 8 nucleated megaspore? 3 generations. 3 generations. First generation, this is the second generation, it is the third generation. First generation of mitosis takes place in single or uninucleated megaspore, result binucleated. At the end of the second generation, tetranucleated. At the end of the third generation, 8 nucleated megaspore is formed. 8 nucleated megaspore. From this stage onwards, we can use another name for this megaspore, that is an embryo sac. The term embryo sac is applicable from 8 nucleated stage onwards. It is the development of an embryo sac. Simply, we can ask a question here also. To form a complete embryo sac, how many mitotic generations are needed? 3 mitotic generations. 3 mitotic generations. It is a fully developed megaspore, nothing but embryo sac. Another name of this embryo sac is the female gametophyte. Female gametophyte. Other name of the female gametophyte is embryo sac. Here, be careful to listen some kind of concepts here. In 3 types of mitotic generations, only karyokinesis occurs without cytokinesis. You learn in 8th or 9th class mitotic cell division concept. For example, it is a cell with a nucleus. As a result of the karyokinesis, it gives rise to just 2 nuclear status of the cell. KK, karyokinesis. Karyo means nucleus. Nucleus is the English name. Technical name or scientific name is the karyo. Kinesis, division. Kinesis, division. So due to the nuclear division, 2 daughter nucleus are formed. At the end of the mitotic cell division, as a result of the cytokinesis, cytoplasm is also divided and both the nucleus are separated and this entire cell becomes as a 2 daughter cell. So to yield 2 daughter cells from one mother cell, these 2 phases of the mitosis is essential. One is the karyokinesis, another one is cytokinesis. Cytokinesis. Whereas in this development of an embryo sac, in first 3 generations, only karyokinesis occurs without following cytokinesis. Without following cytokinesis, only karyokinesis. That's why it is the first nuclear division, second nuclear division, third nuclear division. There is no cytokinesis here. That's why more than 1 nucleus are formed in the single cell. What is the reason for the presence of more than 1 nuclei or exactly 8 nuclei in the cell? Lack of cytokinesis or continuous limited number of karyokinesis without cytokinesis leads to multikaryotic condition. Multikaryotic condition. At the end of the 3 mitotic karyokinesis, finally we can get 8 nucleus. In this 8, 4 nucleus are present at one side. One side means it may be either micropylar area or micropylar end. Other end is called as the chalajal end. Chalajal end. 4 nucleus are found at one side, another 4 present in opposite side. Gradually, among these 4, one migrated towards the center from polar area. It is the micropylar polar region. These 4 are also present at chalajal end. It is also a kind of pole. Among these 4, one migrating towards the center. Then that 4 plus 4 arrangement of nucleus turn into 3 plus 2 plus 3 arrangement of nucleus. Out of 4, 1 migrated towards equator from pole. In the second pole also, out of 4, 1 migrate towards equator area. Then 4 plus 4 arrangement of nucleus become as 3 plus 2 plus 3 arrangement. 3 plus 2 plus 3 arrangement. It is an embryo sac or female gametophyte. Out of 4 nuclei, only 3 remains in this area. One is migrated towards the center. Center nothing but equator area. In opposite pole also, only 3 remains. One migrate towards center. After completion of this arrangement, 3 plus 2 plus 3. Now it is the time for formation of cell wall. Cell wall formation. Okay. Around each nucleus, along with some amount of cytoplasm, a new cell wall is formed. Then this nucleus becomes as a cells. The nuclear status turn into cellular status. In opposite also same thing is happening. This one nucleus become as a one cell, second cell formation, third cell formation. But at the center entire this area become as a one single cell. But the cell possesses two polar nuclei. This arrangement of cells we can write it is as 3 plus 3. This entire embryo sac structure, total number of nuclei 8 nucleus, but total number of cells are 7 only. 1, 2, 3. 3 cells in one polar zone, another 3 cells in second polar zone, 3 plus 3. At the center, entire this area will consider as one separate cell. So that is the central cell. Number of cells 7, but number of nucleus are 8. It is the 7-celled, 8-nucleated embryo sac. 7-celled, 8-nucleated embryo sac. What is the arrangement of this 8 nucleus? 3 plus 2 plus 3. What is the arrangement of cells? 3 plus 1 plus 3. So arrangement of nucleus and the cells is the difference in embryo sac structure. 3 plus 2 plus 3 is the nucleus arrangement. 3 plus 1 plus 3 is the cellular arrangement. It is one mature, typical embryo sac or female gametophyte in majority of the flowering plants. These two are polar nuclei in entire cell, central cell. One central cell possesses two polar nuclei. One chalagal end, chalagal side of the chalaja, 3 antipodals are there. 3 antipodals. Micropylar side, synergids are present and one egg is there. Chalagal side, micropylar side. This image exactly opposite to this image in terms of both the ends. Towards the chalagal side, 3 antipodals are there. Towards the micropylar side, also 3 cells are there. One is the egg cell, 2 are synergids, both single egg and 2 synergids together called egg apparatus. Egg apparatus. Egg apparatus consisting of 3 cells. Among these 3, one is the egg, remaining 2 are synergids. In this diagram, these 2 are synergids. At the back side of the synergid, one egg cell is present. One egg cell is there. So remaining entire this area is occupied by central cell. The central cell has the 2 polar nuclei. So total number of cells 3 plus 1 plus 3, 7 cells. Total number of nuclei 3 plus 2 polar nucleus and 3 in egg apparatus, 8 nucleus. Okay. What kind of cells are found towards the chalagal side? One question. Name of the three cells found towards the chelagel end. Antipodals. These are smallest cells of an embryo sac. Antipodal cells are smallest cells of an embryo sac. Name the three cells in an egg apparator found at the micropylar end. In micropylar end also three cells are there. Among these three, one is the egg, remaining two are synergids. Now the three cells together called egg apparator. The place of egg apparator, micropylar end. The place of antipodals, chelagel end. Remaining entire area is the central cell. Answer for question. Smallest cells of embryo sac. Smallest cells of an embryo sac. Antipodals. Largest cell of an embryo sac. Central cell occupy maximum 80% volume of the entire embryo sac. Within the egg apparator, means out of three cells, larger one is the egg. In overall embryo sac, largest cell is the central cell. Within the egg apparator, large cell is egg. Egg cell size is the bigger than that of two synergids. Yes. Some model questions are there here. Answer. Mother cell of male gametophyte in angiosperm is female gametophyte, sorry. What is the mother cell of female gametophyte in angiosperm? Megaspore mother cell or female gamete or functional megaspore or functional microspore? Other name of the female gametophyte is embryo sac. I am asking about what is the first cell or mother cell for development of this female gametophyte. Name of mother cell. Yes, fourth option, right answer. Functional megaspore. It is the functional megaspore, 3 degenerate megaspore. It gives rise to an embryo sac with 3 antipodals, one synergid, 2 synergids and egg, central cell. What is the first cell for the development of this functional megaspore? MMC, megaspore mother cell is the mother of megaspore. Megaspore is the mother of embryo sac. So what is the relation between embryo sac to megaspore mother cell? Megaspore mother cell is the grandmother of embryo sac. Megaspore mother cell is the grandmother of an embryo sac. Next question here only. What kind of cell division is essential to develop functional megaspore from megaspore mother cell? What type of cell division? Reductional division or meiosis? Whereas in the development of an embryo sac from the functional megaspore, mitotic, 3 mitotic generations are essential. 3 mitotic cell division. It is the overall development of an embryo sac from megaspore mother cells found in ovule. Once again, concentrate here. Meiosis is essential to produce megaspores from megaspore mother cell, but mitosis is essential to develop an embryo sac from functional megaspore. Next question. Identify the sequence or correct sequence of the development of an embryo sac. Recently have learned. Identify. The correct sequential development of all the cells in this embryo sac formation. Answer. Right, very good. Third option. Nucellar tissue found in ovule. So many lakhs of nucellar cells are there in the tissue. only one is modified into megaspore mother cell out of millions of cells that undergo meiotic cell division or reductional division to form single functional megaspore. After 3 mitotic generations, it gives rise to a female gametophyte. Other name of this female gametophyte is an embryo sac. It is the correct process or correct sequential of different cells arranged in development of an embryo sac from nuclear tissue. This is the structure of an embryo sac. This image given in our NCERT textbook as it is. But the micropilar side given as downside. Chalajal side given as upper side. Antipodals always present towards chalajal. It is a fixed thing. But egg apparatus always found towards the micropilar side. Number of antipodals 3. Number of central cell only 1. Number of cells in egg apparatus 3. In that single egg 2 synergids are there. 2 synergids. In this embryo sac, total number of cells are 3 plus 1 plus 3, 7. But number of nuclei are 8. In central cell, 2 polar nuclei are there. Pair of polar nuclei are found in single central cell. And another important thing, in this embryo sac, towards the micropilar side, central bigger cell is the, within the egg apparatus, central bigger cell is the egg. Either sides of egg, 2 synergids are present. Pair of synergids. Pair of synergids are found either sides of this egg. The characteristic feature of this synergid, characteristic feature of each synergid, presence of a finger-like projections or filiform apparatus. The name of, technical name of the structure is the filiform apparatus. Presence of filiform apparatus is the characteristic feature of synergids. These 3 cells are called egg apparatus. Within this egg apparatus, filiform apparatus found in 2 cells such are synergids. The cell without filiform apparatus is the egg cell. Another name of egg cell is the female gamete. Female gamete is the another name of egg. Total how many eggs are present in overall embryo sac? Single egg is present. Only one egg is present entire embryo sac. Next, answer for this question. The pattern of cell division, mitotic cell division, involved in functional megaspore. Initially in an angiosperm of the development of an embryo sac. For the development of an embryo sac, what kind of cell division pattern is there? In mitosis, 2 phases of cell division is there. One is the karyokinesis, another one is the cytokinesis. Answer for this question. Yes, the mitosis without cytokinesis. Only karyokinesis occurs without following the cytokinesis. Third option is right answer. Good. Next, one more SSN reason type of question. Development of female gametophyte in most of the angiosperms is called monosporic. In majority of the angiosperm, development of this embryo sac, nothing but female gametophyte is monosporic. Why? Read the reason. Single embryo sac is present in each ovule after megasporogenesis. Single embryo sac is present in each ovule after megasporogenesis. Statement assertion is the true, no doubt. Statement reason is also true. Only one embryo sac is possible to present in each ovule. In plant is whatever it may be, ovule is whatever it may be. Each ovule possesses only one embryo sac. But there is no explanation here. Reason not explains assertion. That's why what is the right answer for this question? Second option, both A and R are true. R is not the correct explanation of assertion. But what is the correct explanation for this assertion? Out of 4 megaspores, 3 degenerated, only 1 functional megaspore is involved in formation of entire 7-celled, 8-nucleated embryo sac. Whereas in few kind of flowering plants, all megaspores also involved in formation of one female gametophyte. But majority of the members, more than 90% of flowering plants, out of 4 megaspores, only 1 functional megaspore involved in development of female gametophyte. Hence, it is named as the monosporic type. That kind of explanation not given in the statement reason. That's why answer for this question is the second option only. Second option only. Next question. Difficult range. Take a challenge to answer for this question. Very, very important. And difficult range question. What is the ratio of the cells present in fully developed male gametophyte and embryo sac? Nothing but female gametophyte, respectively in angiosperms. What is the ratio of maximum number of cells are present in fully developed male and female gametophytes respectively? One is to 2, wrong answer. Fourth option wrong. No. I will draw a diagram. Guess what is the name of this diagram? Germinating pollen grain or germinated pollen grain, nothing but fully developed mature male gametophyte. This kind of male gametophyte development takes place on stigma of carpels. Somebody said 3:7 is the right answer. Female gametophyte or embryo sac. Towards chalazal side 3 cells. Micropylar side 3 cells. At the center 1 cell is there in female gametophyte. Now count number of cells in male gametophyte. 1, 2, 3. One is the vegetative cell, remaining 2 are sperms or male gametes. So maximum number of cells in male gametophyte 3 only. In that 3, one is the vegetative cell, remaining 2 are male gametes or sperms. 2 sperms are there in each male gametophyte. Whereas in female gametophyte, maximum number of cells 1, 2, 3, 4, 5, 6, 7. Then the right answer is the 3:7. Maximum number of cells in male gametophyte 3, female gametophyte 7. In this 3, 2 are male gametes. Whereas in female gametophyte, out of 7, only 1 is the egg. Other name of the egg is female gamete. In entire male gametophyte, 2 male gametes are there. Whereas in entire female gametophyte, single female gamete or egg is present. These are textbook images. Male gametophyte, female gametophyte. In male gametophyte, 2 sperms, 1 vegetative cell. In female gametophyte, single egg, 2 synergids, 1 central cell, 3 antipodals. So structure of embryo sac completed. Next question. Now try to answer for this question. Matured female gametophyte of angiospermic plant is. Answer for this question. 7-celled, but 8 nucleated. Once recall name of these 7 cells. Number of nucleus are 8, but number of cells are 7. Once recollect or recall the name of the 7 cells of this embryo sac. 3 antipodals, 2 synergids, 1 egg, 1 central cell with 2 polar nuclei. Filiform apparatus is found in. Filiform or finger-like projections are found in. Answer for the question. Synergids. Synergids in egg apparatus possess filiform apparatus. Now the cell in egg apparatus are the cells in egg apparatus. What is the correct answer? How many number of cells are found in an egg apparatus? Number of cells in egg apparatus? 3 cells. Maximum number of cells in egg apparatus are 3. In that, 1 is the egg, remaining 2 are synergids. Yes, third option. 1 egg and 2 synergids. 1 egg cell, 2 synergids. Right answer is the third option. Good. Next question. What is the largest cell of an embryo sac? Largest cell of an embryo sac or female gametophyte. Biggest cell. Around more than 80% of the volume of the embryo sac can occupy by that cell. Central cell. But largest cell of an egg apparatus, egg cell is there. In overall embryo sac, biggest cell is the central cell. Likewise, one more question in the same options. What is the smallest cell of an embryo sac? Antipodals. Antipodals. Next question. Binucleated cell or 2 nuclear cell in embryo sac is. Name the cell of an embryo sac that possesses 2 nucleus. Yes, central cell. In that central cell, 2 polar nuclei are present. 2 haploid polar nuclei within the central cell. Okay, but the next our topic is pollination. I will explain from next class onwards. Okay, bye.
All right, no problem. Hello, hello everyone. Am I audible? Am I visible to everyone? Hello, hello. Hi everyone. How are you all, beta? Good morning, good morning, good morning, Swati, Tanmaya, Mallikarjun, Sai, Raj, Surya, Neela Veni, Deepanvita. Hi beta, okay, okay. Manga, beta, I am Madhu Yadav. Myself is Madhu Yadav and I am teaching zoology. Good morning, good morning, good morning. All right, everyone. So let's start our today's class. Are you all excited for today's class, everyone? Okay, Malika Arjuna is saying my name is Shravani. Okay, beta. Okay, Shravani. All right, so let's start our today's class, and I have told you in my last class that I am going to start blood today, right? We have discussed connective tissue in our last class. All right. Oh, one of Madhu is also there in the chats. All right. All right, let's get started, beta. Let's get started with the today's class. So, connective tissue I have discussed in my last class, where I have taught you the 3 types of connective tissue. I have taught you 3 types of connective tissue. One was loose connective tissue, one was dense connective tissue, and one was specialized connective tissue. In the loose connective tissue, I have told you there is areolar tissue, and there is adipose tissue. In the dense connective tissue, I have told you there is dense regular connective tissue, and there is dense irregular connective tissue. Then I have told you in the dense regular, there is tendon and ligament. No further types are there for the dense irregular connective tissue, and specialized connective tissue is of 2 types. One is skeletal connective tissue. Another is fluid connective tissue, beta. In the skeletal connective tissue, we have cartilage and bone. What we have? We have cartilage and bone, because cartilage and bone makes our endoskeleton, right? Now, we are going to discuss fluid connective tissue. If you want to understand the whole connective tissue, this chart, this mind map of the types is very, very important. Sometimes they simply ask this question that areolar tissue is which type of connective tissue? Then the answer will be loose connective tissue. Adipose tissue is which type of connective tissue? Loose connective tissue. Tendon and ligament is type of which connective tissue? Dense connective tissue. Which type of dense connective tissue? Dense regular connective tissue. So you should remember these terms. You should remember this classification, types of the connective tissue. Now I am going to discuss a very, very important thing which you all have in your body, without which your nutrients will not be circulating. Your oxygen, you are taking oxygen from the outside, from your environment, you are taking oxygen. That oxygen, how it is going to each and every cell and tissue and organ of your body? Through the only and only one circulating fluid in your body, and that is blood. So that is the fluid connective tissue. In the fluid connective tissue, we will talk about blood today. One is blood, beta, another is lymph. If I will get some time, I will explain you lymph in brief, but mostly we are going to discuss blood today. Blood, very, very important, right? Blood is very important. So I am going to discuss blood now. Let me tell you, blood has 2 parts. Beta, blood has 2 parts. One is the plasma, and other is known as formed elements. Other is known as what? Formed elements. This plasma part is the fluid part, right? Blood is a fluid already, but in the blood, few other things are there, like some cells are there. You know your blood cells. Can you name some blood cells? Yes, everyone. Can you name some of the cells in the blood? Can you tell me some of the cells which are present in the blood? Yes, WBC, RBC. Yes, very good. Yes, very good. WBC, RBC, and the cell fragments also are present. Platelets. Yes, very good. Right? So, these are the formed elements. So, this RBC, WBC, they are present in a fluid. That fluid part, or you can say fluid matrix, is plasma. It is major part. 55% of the blood is plasma, beta. 55% of the blood is plasma and rest 45% is formed elements. So, which part is more in blood? Plasma is more or formed elements is more? Plasma is more, right? Now, in this plasma, let us write that this plasma is the fluid part of blood. This is beta fluid part of blood. And in this fluid part, what is the color of this fluid part? It is pale yellow in color, pale yellow. What is the color of plasma? Pale yellow, or you can say straw colored. It is a straw colored fluid, straw colored, or you can say pale yellow, right? So we will now discuss the composition of plasma. First, we are going to understand about the plasma and then we will talk about the formed elements. But let me tell you, formed elements are RBCs, WBCs and platelets. These collectively, platelets. So, these things collectively are called as, these things collectively are called as formed elements, platelets. So, RBC, WBC, platelets. These three things in the blood collectively called as formed elements. Are you understanding? Are you understanding that what is the difference between plasma and formed elements? In your blood, there is a fluid part that is known as plasma. Now we are going to discuss plasma, right? Now we are going to discuss plasma. After that, we will discuss formed elements. So let me begin with the plasma. Beta, plasma has so many things. Plasma is a fluid part. So obviously, major fluid is water, beta. In the plasma, 90 to 92% is water, H2O, water. And the rest 6 to 8%, next 6 to 8% is the dissolved solids, right? So, majority 90 or 92% is water and 8% are the dissolved solids, right? If 92% is water, 8% are the dissolved solids. What is the meaning of this dissolved solids? See, water is there and in the water, few things are dissolved, like glucose is dissolved. Let us know how to make a, lemonade. When you make a lemonade, then in the water, you will mix sugar or jaggery. Yes, for the sweetness. Then you will also mix some little bit of salt. Yes or no? So that sweet and salty flavor. And then you will add lemon juice also. Right? Lemon juice also. So just like that, here also in the blood, in the plasma, water is there. Maximum water is there. 90 to 92% water is there. Rest things are dissolved in this water and these dissolved things are known as dissolved solids. So what all things are dissolved? What all things are dissolved? In these dissolved solids, nutrients will be there, beta. Nutrients. What type of nutrients will be there? Whatever you are eating, through that, whatever you are eating, the food, from that food, whatever nutrients you are getting, that is going into the blood. Where in the blood? Plasma of the blood. Where in plasma? Dissolved solids, right? So glucose, amino acids, right, etc. These type of nutrients will be there. Then gases will be there, beta. Gases like oxygen, carbon dioxide, these gases are dissolved. Then cholesterol can be there. Cholesterol can be there. Urea can be there. Urea is present in your blood. Cholesterol is present in your blood. Then you have clotting factors. Clotting factors, beta, very, very important. If there is any injury, if you will get any cut, right? If you will get any injury, cut, then these clotting factors will help in the blood clotting so that you will not lose so much of your blood. Blood is very precious, important. We don't want to lose blood. Yes, Sai Raj Surya, you are correct. It is fibrinogen. Many clotting factors are there, but the main is fibrinogen. You can write an example that is fibrinogen. Fibrinogen, right? Fibrinogen, prothrombin, thromboplastin, so many clotting factors are there. There's a separate topic in NCERT which will tell you about the process of blood clotting, right? That is in the chapter body fluids and circulation. So now clotting factors are there. What else is there? Anticoagulant is there. You know the name of the anticoagulant. Yes or no? In the last class also we have discussed heparin. It was being secreted from which cells, everyone? Yes, yes, yes. Yes, if you remember the last class, what cells were there which were secreting heparin? Quickly tell me. What are the cells which secrete heparin? I have shown you those cells. I have told you the name of that cell which secretes heparin, histamine, serotonin. Yes, quickly tell me. No, beta. Fibroblast was secreting fibers. Fibroblast was secreting fibers. Yes, so now the correct answers are coming. Mast cells, mast cells. Mast cells were secreting heparin. Yes, correct. Correct, absolutely correct. Mast cells were secreting heparin. So, heparin is there, right? Then electrolytes are there. What else is there, beta? Electrolytes are there. Salts are there, right? Ions are there. So nutrients, gases, cholesterol, urea, clotting factors, anticoagulant, hormones, very, very important. Hormones are there. Hormones are also dissolved. Hormones. You have so many glands, endocrine glands, which are secreting the hormones. Yes, the Viber. Yes, you were the first to tell the correct answer. Mast cell. Yes, beta. All right. So you must have understood the things which are dissolved in the plasma, beta. Yes, you must have understood the things which are dissolved in the plasma. So that is why we tell blood glucose level, blood urea level, blood cholesterol level, because that urea, cholesterol, hormones, gases, glucose, right? Amino acid, everything is dissolved in the plasma, and plasma is the part of the blood. So now we have discussed the plasma in brief. Now we are going to discuss the formed elements. So after this, we are going to discuss the formed elements. So what are the formed elements? Formed elements are, beta, they are of three types. One is the RBCs, red blood cells, or you can say red blood corpuscles, or you can say erythrocytes, RBC, red blood cell, or erythrocyte, right everyone? RBC or erythrocytes. The next formed element is our WBC, white blood cell, WBC, white blood cell, WBCs, or they are known as leukocytes. They can also be called as white blood cells or white blood corpuscles. White blood corpuscles. Right? Then there is another formed element, that is platelet beta. Platelets. They can also be called as platelets. They can also be called as thrombocytes. They can also be called as what? Thrombocytes. Thrombocytes. So these are the main formed elements in your blood: RBC, WBC and platelets. RBC, WBC and platelets. So now I will be telling you few things about all the three: RBC, WBC and platelet. Let us discuss first of all the color. Let us discuss first of all the color and the shape of the RBC, WBC and platelet. If you see the color and structure beta, if you will see the color and structure, then you can tell me what is the color and structure of RBC. Color of the RBC is red. Yes or no? Structure of the RBC is round. Round. Biconcave. You know already, biconcave, and there is no nucleus. It is enucleated. Why? Because the space inside the RBC is occupied by hemoglobin. Do you know about hemoglobin? Hemoglobin is a very, very important protein present in your RBC. Never ever you should say hemoglobin is present in the plasma. No, it is not present in the plasma beta. Hemoglobin is present inside the RBC. If it is present inside the RBC, then RBC should not have the nucleus. It should have a lots of space. So RBC does not have nucleus. RBC does not have the cell organelles. This is a cell which does not have the nucleus and cell organelles. It has a lot of space for the hemoglobin, right? So it is enucleated. Then WBC is obviously white. That is why its name is white. White blood cell. It does not have any shape. It is irregularly shaped. It does not have a specific shape. So it is irregularly shaped. It is irregularly shaped. Right? And yes, it has the nucleus beta. They are nucleated. Their nucleus is of different types. We will see different types of WBCs, and different WBCs have different nucleus. Right? Then coming to the platelets beta. So platelets are not the cells. Platelets, first of all, they are not the cells. They are the fragments of the cell, and that cell is megakaryocyte. Platelets are the fragments of megakaryocyte. Mega means big, karyo means nucleus, and cyte means cell. Mega means big, karyo means nucleus, and cyte means cell. So megakaryocyte is that cell, that cell which has a large nucleus, and it is, it is fragmented, and the fragments of the cell megakaryocyte, they are known as platelets. Now, where is this megakaryocyte present? This megakaryocyte is present in the bone marrow. You have bones, right? Inside the bone, there is a cavity which is filled with a fluid, and that fluid is known as bone marrow, right? So, that megakaryocyte is present in bone marrow. This megakaryocyte is present in bone marrow. This is a cell which is present in bone marrow. So, platelets are the fragments. They are not the cells, but obviously, so then they will be irregularly shaped. But if we see the color of the platelets, it is also, white. It can be stained. RBCs does not require stain. WBCs and platelets, they require staining. If we want to see under the microscope the WBCs and platelets, we need to stain them beta. Stain, right? Stain is used. So they are also white in color. Now we have discussed their color and structure. Now let us discuss their normal count. Their normal count. And then I will tell you what we call the increased amount and decreased amount. What is the term used for representing increased amount and decreased amount? So first of all, normal count of RBC in males will be different and in females will be different. In males, beta, it is little more than the females. It is 5.5 to 5.5 million per cubic millimeter of blood. This is the unit per cubic millimeter of blood. In females, it is little less, 4 to 4.5 million per cubic millimeter of blood. So, if somebody will ask you which is the most abundant cell in the blood, which is the most abundant cell in the blood, then it will be RBC. Most abundant cell, most abundant blood cell will be RBC. Right everyone? RBC. If you see the WBC, let me make a line here. Right, so if you see the WBC beta, then WBC is how much? The total leukocyte count. So many WBCs are there. So I will tell TLC. TLC stands for total leukocyte count. Total leukocyte count. That is 6,000 to 8,000 per cubic millimeter of blood. Per cubic millimeter of blood. 6,000 to 8,000. So WBC is in thousands, beta. Thousands. Right? WBC is in 1,000. RBC is in million. And platelets are in lakhs. Yes, in some of the diseases you must have gone to the doctor, and after checking your blood, there is a blood test report in which if they will tell you that platelet count is less, that means platelets have decreased in your body. Mainly in which type of diseases? In dengue. Yes or no? Platelet count will be decreased in case of dengue. Right? So, you should know what is your normal count. Normal count of platelets is beta 1.5 to 3 lakhs. 1.5 to 3 lakhs per cubic millimeter of blood. Per cubic millimeter of blood. So, this is the normal count. RBC is in millions, WBC is in thousands, platelets is in lakhs. Now, increased amount of RBC is known as erythrocytosis, or it can be called as polycythemia. Polycythemia. Whereas decreased amount is known as erythrocytopenia. Wherever there is penia, that means decreased amount. Wherever there is cytosis, that means increased amount. Similarly, for the WBC, it is leukocytosis, or you can say leukemia. What is leukemia? Can anybody tell? Can anybody tell me what is leukemia, beta? What is leukemia? Venkata, increased rate of WBC is leukocytosis. Yes, beta, leukocytosis. You are correct. Leukemia is also increased, and decreased is leukocytopenia. Yes, correct. Alright. So, what is the leukemia? What is the common name of leukemia? Can anybody tell? Common name of leukemia. Where you have heard of leukemia? You must have heard of leukemia. Yes or no? You must have heard of leukemia. I'm sure you must have heard of leukemia, cancer. Yes, yes. Venkat Shiva Kumari. Yes, you are correct. It is cancer, blood cancer. Yes, absolutely correct. It is blood cancer, beta. So if somebody will ask you in blood cancer, which blood cells are increased in amount? Which blood cells are increased in number? So in blood cancer, not all the blood cells are increased. Not RBCs are increased. Not platelets are increased. WBCs are increased. Which blood cells are increased in blood cancer? WBCs, white blood cells, WBCs. So it can be called as leukemia, blood cancer. Then thrombocytosis, increased amount of platelets, decreased amount of WBC, leukocytopenia or simply leukopenia, decreased amount of platelet, thrombocytopenia, right. Now what is the process of formation? Formation is known as what? Formation of RBC, formation of WBC, formation of platelets is known as what? Formation is known as what, beta? Formation is known as what? So formation of RBC is known as erythropoiesis. Formation of WBC, beta, it is known as leukopoiesis. Very, very easy and important to learn. Thrombopoiesis. All these things are collectively called as hemopoiesis. Erythropoiesis, thrombopoiesis, leukopoiesis. All these collectively called as hemopoiesis, formation of blood cells. Where it occurs? Where all the blood cells are forming in your body? Yes, everyone. Can anybody tell where all these blood cells are forming in our body? Yes. Tell me in the comment section where all these things are getting formed in our blood. Yes, very good, Rohit. Bone marrow, not plasma. It is not plasma, it is bone marrow. Yes, Swati. Yes, Shiva. It is bone marrow. Absolutely correct. You all are absolutely correct. Bone marrow, beta. Bone marrow. So next is the function, beta. Next is the function. What is the function of RBCs? What is the function of RBCs? Yes, tell me the function of RBCs. The function of RBC is, what is the function? The function of RBC is transport of gases, gaseous transport of gases. Which gases? Oxygen, carbon dioxide. What is the function of WBCs? WBCs are protecting us from the pathogens. They are the part of the immune system. So they are protection, immunity. They are providing immunity, protection and immunity mainly, right? And what is the function of platelets? Blood clotting. They help in the process of blood clotting. Platelets help in the process of blood clotting. So you should know all these things about the formed elements. You should know the color and structure of RBC and WBC and platelet. You should know the normal count. You should know what is the name of, what is the term given to increased amount, what is the term given to decreased amount, what is the term given to its formation. You should know what is the formation of RBC, WBC, platelet is known as, and what is the function. What is the function of all these formed elements. So with the help of a table, I have told you all these things about RBC, WBC and platelets. Isn't it easy? Yes or no, everyone? Isn't it easy? In this way, if you will learn about the things in a kind of a flow chart or in a kind of a table, it will be very easy for you to understand and it will be very easy for you to learn. Learning is important. If you have understood all the formed elements, please give a thumbs up in the comments. Tell me in the comments yes or no. Are you understanding everything? Yes or no? Yes, clear, clear, clear. All right. All right, my lovely students, let's go ahead and let us discuss the types of WBCs. The formed elements are not yet completed without discussing about the types of WBCs. So now I'm going to tell you the types of WBC. But before that, I am going to tell you a very, very important and interesting thing. So let us go to the next page. I have told you what is hematopoiesis. Collectively, all the formation of all the formed elements is known as hematopoiesis. Formation of blood cells. Hematopoiesis is formation of blood cells. Formation of formed elements. Formation of RBCs, WBCs and platelets collectively. Formation of RBC, WBCs and platelets collectively is known as hematopoiesis. So where it occurs, you know only one thing. You know it occurs in. You have told me it occurs in. So beta, let me tell you, it is not only occurring in the bone marrow. It is occurring in the bone marrow, but not only occurring in the bone marrow. It can also occur in the yolk sac, which is a structure present in the embryo, embryonic life, embryo. We are not embryo now, we are adults. A human baby is an adult. But when the human baby is inside the womb of the mother, then it is known as an embryo, right? So in the embryo, in the early embryonic stage, there is yolk sac. Then after the formation of liver and spleen in the embryo, hematopoiesis also occurs in liver and spleen. So if somebody will ask you when it occurs in the yolk sac, in early embryonic stage, during early embryonic stage, during early embryonic stages, right? When it occurs in liver and spleen, during late embryonic stage, during late embryonic stage, during the embryonic life only, it occurs in yolk sac, liver and spleen. But now the liver, yolk sac is not there. Liver and spleen has different functions, right? Liver and spleen has different functions and hematopoiesis occurring in bone marrow. So in adults, or you can say after birth, it occurs in bone marrow. After taking birth, it occurs in bone marrow. Yes, Dikshita, spleen is the graveyard of RBCs. When RBCs will die, then they will go to the spleen. Yes, what is the lifespan of RBC, WBC and platelet? We have not discussed. Yes, you can write it as well. What is the lifespan of RBC, WBC and platelets? Okay, this is your homework. You will find out and write in your table. You must be knowing the lifespan of RBC, 120 days. So after 120 days, it will die. Where it will go? To the spleen. That is why graveyard of RBC. Spleen is the graveyard of RBC. Right? Alright. Let us move ahead and let us discuss the types of WBC quickly because we have very less time now. WBCs beta. WBCs are of two types first of all. Two types. One is granulocytes. Granulocytes. Other is agranulocytes. Agranulocytes. A means absent. A means absent. Means granules are absent. Granules are absent. Neela Veni, thank you so much, beta. Thank you. She is praising my handwriting. Thank you so much. Alright. So, granulocytes and agranulocytes. Granulocytes, granules are present, beta. Which granules? In the cytoplasm. Some granules are present. They are known as cytoplasmic granules. So they are present. Whereas in agranulocytes, the cytoplasmic granules are absent. Right? Then granulocytes are further of 3 types. Granulocytes are of 3 types. What are these 3 types, beta? These are neutrophil, basophils, and eosinophils, or they are also known as acidophils. Agranulocytes are of 2 types. Monocytes and beta lymphocytes. So all these 5 types of WBCs, total how many types? 5 types. Total how many types? 5 types, beta. 3 are the granulocytes, granules are present. 2 are agranulocytes, no granules, right? Now the very important and most commonly asked question is about their percentage. If somebody will ask you which of the WBC is most abundant WBC, yes, anybody knows most abundant WBC? Most abundant WBC is neutrophil, 60 to 65%. Most abundant WBC. No, beta, it is not lymphocytes. Beta. It is neutrophils. Neutrophils are the most abundant WBC. If somebody will ask you which of the following is least abundant, which of these is least abundant? It is basophil, 0 to 1%. Among the total WBCs, 60 to 65% is neutrophil, 0 to 1% is basophil. Then 2 to 3% is eosinophils, 6 to 8% is monocytes, and 20 to 25% is lymphocytes, beta. But mostly they will ask you about the most abundant and least abundant. All these are, in the nucleus, the shape of the nucleus is different in all these. The shape of the nucleus is different. Thank you, beta, Neelaveni. This is my style, है ना? And this is, my love for the students. That's why I again and again tell you, beta, you all are my lovely kids. All right, everyone. So neutrophils are most abundant, basophils are least abundant. I can show you these because we have very less time, so I will not be drawing these. So I will be showing you these from the NCERT. Let us have a look at these cells. Are you able to see these cells, beta? So what are these cells? These are the formed elements. If you see RBC, red blood cell, you can see platelets, fragments. These are the fragments of the megakaryocyte. Then you can see 5, 1, 2, 3, 4, 5, 6. This is lymphocyte, right? This is lymphocyte. So 5 types you can see. 5 types. Eosinophil, basophil, neutrophil are. All these 3 are granulocyte. Basophils are just like mast cells, beta. Basophils are just like mast cell. You know the function of mast cell. It is the same function of the basophil. It also secretes histamine, serotonin and heparin. है ना? Basophils is also secreting histamine, serotonin and heparin. Now let me show you the nucleus. If you see the eosinophil nucleus, it is just like a headphone. Can you see here? Some of you must be using headphones for your class, na? Headphone. bilobed nucleus or headphone shaped nucleus, eosinophil. Right, neutrophil has, so many lobes. You can see so many lobes in the neutrophil, It is a multi-lobed nucleus. Whereas basophil has a tri-lobed nucleus or S-shaped nucleus, or you can say tri-lobed nucleus. So shape of nucleus is different. If somebody will ask you which of the WBC is largest in size, not largest in number. Largest in number is neutrophil. Largest in size. Can anybody see and tell? Largest in size, beta. Yes, beta, tell me. Largest in size. Quickly, 1 minute is left. Let us conclude. Largest, monocyte. Very, very good. Monocyte is largest in size and it has a large bean-shaped nucleus, kidney-shaped nucleus, bean-shaped nucleus. In basophil, you can see there is a round nucleus. In lymphocyte, there is a round nucleus. Lymphocytes are of two types, B lymphocytes, T lymphocytes. Right, so these all are the types of WBCs. We will discuss more in detail once you will come here and once I will start body fluids and circulation chapter, each and everything in detail. Now simply the brief, right? So now you have seen the types of WBCs, then you have seen the types of formed elements, RBC, WBC, platelets. All these things are the formed elements, and the another part is plasma. Plasma plus formed elements makes the blood. So today you have understood about the blood. Yes or no, everyone? Today you have understood about the blood. I hope you have understood everything. I hope you liked this session, right? So if you have learned at least something, then please like this session. Those who have not liked the session, just now, right now, please hit the like button, right? So that was all about today's session, right? And just subscribe to the channel so that more videos will be coming and you will be updated for the more videos, right? So now see you in the next class tomorrow, right? Tomorrow let us continue with the animal tissues. So I will be teaching tomorrow about the muscles, right? Muscular tissue I will teach tomorrow. Okay then, bye lovely students. See you tomorrow. Bye bye. Take care. God bless you all.